Dr. Joaquín.
Yes.
Yes. Just keep on moving with your presentation.
Yes. Do you see my screen, please?
Yes. I can see your screen. Just keep on going with your presentation.
Yes, I can.
Yes. Okay.
Okay.
Next slide, please.
Okay. First of all, thank you all to attend at this presentation and the committee organization of this event. The topic of this presentation is related with the biogas cleaning. Inside of the biogas cleaning, the technology for biogas cleaning BTS-MPdry, yes, an efficient way to remove impurity from biogas. This will be our topic presentation. This is the indices of the presentation, the introduction, topic development, case of the studio, in this case, an example of the real plan working on in Madrid, Spain, Alcalá Oeste water treatment plant, result of the study and conclusion. When we talk about biogas plant, we can distinguish different parts inside of the biogas plant. In this case, the biogas production, digestate treatment, and gas purification. Take into account when the biogas take out or come out of the biodigester is a dirty gas that requires prior purification to be used as raw material for energy production by combined heat and power, or produce another product like biomethane, methanol, and hydrogen. What is the topic really? There are different definitions or concepts about biogas, but for the technical point of view, in this case, biogas is a gas mixture that has two main parts. One part is the very important that contains methane and other components like CO2, nitrogen, oxygen, and so on. And the second part is related with the dangerous component or pollutant inside of the biogas, like hydrogen sulfide, water vapor, siloxane, and hydrocarbon. All these traces are dangerous for the application in any other application. Oh, therefore, this gas is considered a dirty gas. It requires prior cleaning in order to be used as raw material for energy production or for the other products. Currently, according to production source or its origin, we can find two kinds of biogas. Biogas coming from uncontrolled process, for example, landfill, lake, and swamp, and biogas coming from control process, for example, wastewater treatment plant, and so on. As you can see in this table, this is the mailing feature and different components, in this case, of the different biogas, depending on the source production, control process, or uncontrolled or no control process. In this case, appear both the mailing composition of biogas and the dangerous composition of the biogas in all cases. In this case, as you can see in the control process, yes, one of the features is that has a level content of methane, level less content of CO2, high content of hydrogen production, low content of nitrogen and oxygen. While the biogas coming from of the no control process, like landfill, is one of the features that he has a low level of methane, high level of CO2, and high level of the nitrogen and oxygen. For that reason, when we use this kind of biogas to produce other products like biomethane, it's preferred to get the biogas coming from uncontrolled process. Here in this column appear the different effects that have different components of the biogas. What kind of impurity we are found in the biogas stream? Whatever be its origin or its source, the biogas, I repeat, is a dirty gas. In the biogas appear two types impurity. External impurity, they are not part of the biogas fluid, removed, and generally it is removed by mechanical operation like filtration or change in the dimension or direction of the biogas fluid. Example, sediment, foam, particles, and condensates. This impurity are mainly found in the biogas when the biogas stream leaving the digester, mainly in the wastewater treatment plant. In this case, this biogas cleaning is defined as gross removal. The second impurity are the internal impurity. They are part of the biogas fluid. They are usually the last removal by different techniques like physical, chemical, biological technique, or combination of these techniques. And for example, waste water vapor, siloxane, hydrogen, ammonia, and sulfide. In this case, this kind of biogas cleaning is defined as fine removal or pollution biogas. In this case, appear different internal impurities and its effect in the fat biogas facility. In this case, water vapor or humidity decrease the low heat volume, allow the corrosive acid production of formation, so sulfuric acid, and accumulation, and its accumulation cause blockage in pipe and when we work with a low temperature, or when the season is winter, it's called season like winter. It could be provoked ice formation. Yes, here appeared how is formed this condensates and accumulation in the pipe. Another impurity, hydrocarbon. In these two types of hydrocarbon, halogenate hydrocarbon, mainly that have chlorine and fluorine, that cause that cause corrosion in different parts of the machine. The heavy hydrocarbon, when the concentration is high, more or less high than 3,000 milligrams per normal meter cubical, can produce fire to work in the engine, as well as is the mainly responsible to the presence of the aldehyde in the exhaust gases. On the other hand, hydrogen sulfide could be produce corrosion in engine, formation of the other gas acids, and poisoning the lubricant oil. In the case of the siloxane, it lay on the engine, internal part, increase the clearance between moving part and feedback part, and lubrication oil leak, or lose the lubrication oil.
It's completely empty.
What are the biogas cleaning techniques currently appear in the market? So sorry. Currently appear three kinds of biogas cleaning technique: a specific technique, general technique, and combined technique. The specific technique going to remove only one component. For example, H2 removal, water vapor removal, or siloxane removal. In this case, appear the biochemical scrubber, dryer, membrane, etc., technology. For the general removal, more than one component, in this case, absorption on active carbon, that allow at the same time removal siloxane, halogenate hydrocarbon, hydrogen sulfide, humidity, and so on. And the combined technique is in a state of simultaneous working. For example, drying active carbon. This is our technology, BTS-MPdry, and the sulfurization, drying, and so on. What is the part of the biogas cleaning facility? Okay, in the case, there are three main parts of the biogas cleaning facility or the purification technology: biogas desulfuration, biogas drying, and biogas polishing. Biogas desulfuration is from H2S removal. This can play in source, that's in origin. For example, chemical dosing on the over digested, oxygen or air injection, thermal or biological hydrolysis. In the biogas line, the desulfuration is over the biogas flue. In this case, it's useful for wastewater treatment plant and landfill and so on, and could be by physical, chemical, biochemical, and biological technique. The other part of the biogas cleaning is biogas drying. This is water vapor removal, another component when you work at temperature down 10 Celsius degree. For example, volatile organic compound, hydrogen, siloxane, depending on the working temperature. And in this case, condensation and drying technique are the most common applied in this case. And biogas polishing, mainly by active carbon filter, to remove all the pollutant trace, like hydrogen sulfide, siloxane, and hydrocarbon. This is the case of the student, wastewater treatment plant Cala Oeste, Madrid, Spain, and this is the technology. It's a combined technique. In this case, combine the drying with active carbon. Okay. This is the flow diagram of this technology. This technology, as you can see, it has two main parts. This part related with the drying, okay, and this part related with the polishing or biogas polishing. In the case of biogas polishing or absorption in active carbon. In this case of the cooling in the drying system, have to make two parts of the cooling. Cooling in this case is based by energy recovery, okay, with water, and by the cooling system. In this case, the cooling system it has two parts: thermal cooling and mechanical cooling, combined with condensation and mixed or droplet separator. Okay, in this case, the biogas flue enter get into the drying system for the energy recovery. Okay, and using in this case the cooling biogas to cool the biogas. In this case, when the cooling biogas get out of the energy recovery, the relative humidity is low, and for that reason is a very good condition to get into the polishing system, or in this case to the active carbon absorption. Okay, in this way, in this part, removal mainly water vapor, heavy hydrocarbon, siloxane, and sulfide, and in this case, removal light hydrocarbon, siloxane, and hydrogen sulfide trace. This is different part related with the know-how that our company put here. In this case, there is removal some traces of sulfide and ammonia due to the breaking down that they play here thermodynamical equilibrium. Here the photo of the facility located in Butarte Wastewater Treatment Plant, Madrid. The economizer is a main part of this system because warranty to minimize the energy consumption of the chiller are often used in the drying equipment. This is a typical use when under the following condition: high biogas flow, more than 500 normal cubic meter per hour, and high biogas temperature higher than 45 Celsius degree. A good design of this equipment allows recovery up to 30% of the energy, and for that reason, the OPEX of the process, mainly of the drying process, is reduced. The design condition that we take place to do this technology is, for example, in the case of the Alcalá Oeste Madrid, Spain, biogas flow 360 nanometer cubic of biogas temperature 38 Celsius degree, biogas pressure 30 millibar, in a temperature of the technology working is around 2 Celsius degree. In this case, based on our research, and the different table appear in different articles. In this case, we working at 2 Celsius degree, we can get water vapor removal around 34 grams of the water vapor by a normal cubic. And working at 2 Celsius degree, in this case, we can get up to 40% of removal of siloxane removal, mainly L2, L3, D3, D4, and D5. This is the fundamental of the design of operation in this case of this technology. What are the result? The result is related with the biogas cleaning and the year of cleaning. Here appear the table, the operational condition, the component before the mailing company, methane, CO2, humidity, and other before biogas treatment, and after biogas treatment, and this is the decrease and increase of the percent of different of the mailing component. And in the down, you can see the pollutant removal, in this case, hydrogen sulfide, mercantile, siloxane, and volatile organic compound. Okay, you can see the removal of water, of vapor water, is reached 91. The hydrogen sulfide 97, yes, and siloxane 18%, and volatile organic percent 10%. Related with the south gas, mainly to this three component is appear in the south gas, the CO2 decrease, the CO3 not report in this case, the bug in this case increase, but this is due to the oil of the lubrication, and aldehyde is is due to the oily lubrication too. But the importance of the table is that all the danger component is slowed down by the limited installation for the south gas emit at the atmosphere. And the profit in this case appear here. The profits for the energy generation appear in this table. Okay, and see this saving, maintenance saving, maintenance cost without BTS biogas treatment system, and maintenance costs with the BTS system. As you can see, at the 10 year, the amount here is possible to get a new combined heat and power system. As conclusion, with biogas cleaning, the following profit can be achieved: optimal machine working, reduce the maintenance costs, the long useful life of the machine and equipment used for pumping, capture and compression, and improving in exhaust gas emission of the engine, and save the staff work due to avoid concentration toxins of the human, mainly aldehyde and hydrogen sulfide. Thank you so much for the for attending. And if any question, I am here, please.
Yes, thank you very much, Mr. Joaquín. Is there anyone to ask questions on this presentation? This is not, I want to continue with backup Kifel. Yeah, Rakeb, you are ready with your presentation?
Sorry?
Rakeb Kifel. Yes, Hans, I hope you are ready with your presentation.
Yes.
Yes, yes. Keep on going with your presentation, Mr. Hans. Yeah, thank you, Mr. Joaquín. Thank you for your presentation.
Thank you.
Yes, Mr. Hans, you can continue with the presentation. Mr. Hans. Yes, is there anyone